All right, today we are doing 6.1 graphing lines. So we're starting a new chapter, so it's going to start out simple and we're going to build and get a little harder each day. All right, our objectives are to graph linear equations. Okay, notice the word line inside of linear. Okay, that means we're going to be graphing lines on the coordinate plane using ordered pairs. And we're going to determine the x and y intercepts of a linear equation. An intercept is the same thing as like an intersection. All right, it's when the line, or where, not when, but where the line crosses x and where the line we're graphing crosses y. That's all an intercept is. All right, so linear functions or linear equations, again, notice this word line in there. They make a straight line. Okay, they form a straight line. So we might have f of x equals 2x plus 7. So remember, this is function notation, this f of x. Or we might have y equals 2x plus 7. And that's just an equation. So we can have a function or an equation, either one. All right, in example 1, it says graph the equation, or graph x and y such that y equals x plus 5. I've got a hint here for you. Make a table of points to help you. All right, so 2 points determine a line, and you need to find a third just to make sure. So it's always good to have positives and negatives. All right, so this is going to be our x column. We're going to write our equation in here, so y equals x plus 5. And this is where we could write our x and our y, our ordered pair. So you pick 3 points. So I'm going to do -2, 0, and +2. If you recall the other day, I told you 5 lines when we were working on domain and range. 5 is great too, but you have to have at least 3 to make a line. You'll learn that 5 is actually better down the road. But, all right, so we're going to plug our x value into our equation here. Okay, the other way to think about this is that x plus 5 equals our y. So if we do that, we have -2 for our x plus 5. -2 plus 5 equals a +3. So that 3 is our y value. So we have -2, 3. And I'm going to go ahead and graph that. So -2, 1, 2 to the left, and 3 up. 1, 2, 3. Next, my x is 0. So 0 plus 5 equals 5. So my coordinate here is 0, 5. I'm going to graph that. So 0, I don't go left or right at all. I stay right at 0, and I go up 5. 1, 2, 3, 4, 5. And my last x is 2. So I'm going to put it in for x in my equation. So 2 plus 5 should equal my y, which is 7. So 2, 7 is my ordered pair. And I'm going to graph that. So right 2, 1, 2, up 7. 1, 2, 3, 4, 5, 6, 7. Okay. Now, this is an equation, okay, that they gave us, and they did not restrict our domain. They didn't say, you know, x values of 2, 0, -2. We picked those. So that means that this needs to be that line that continues. Okay. We connect those points and draw a continuous line. All right. Next up, we're going to move to standard form. All right, so we just talked about how to graph an equation. A lot of this should be review, okay, from middle school math. So we're going to move on a little bit. All right, so standard form of a linear equation, there is ax plus by equals c. We call this standard form. All right, so we're going to use standard form occasionally, and then we're going to learn how to manipulate it into a part that we can graph, because that's not what it looked like earlier when we graphed it. But in this form, a, so the a here should always be a positive number. And the other the other rule is if A, B, or C, so any of those numbers in front of your variable or the constant are fractions or decimals, we actually would multiply them to make them integers. That's like best practice things to do. All right, so let's look at example 2. It says, write the function f of x equals negative 5/7 x plus 2 as a linear equation in standard form. Okay, so we're wanting to write it in standard form. Currently, this, okay, is called slope-intercept form. All right, so the way that this is written is slope-intercept form. So the first thing we're going to do is we're going to write the function as an equation. So instead of having f of x, I'm going to replace that with y. So y equals negative 5/7 x plus 2. That's all. Step 1. Okay, check. 2. Balance the equation as needed to get standard form. So ax plus by equals c. Okay, notice that the x and the y are on the left-hand side of our equal sign. Well, currently we have the y on the left, right? Here's our equal sign, but our x is over here. So we need to balance and move it. So we're going to add 5/7 x because it was a negative, so we're adding it so that those will cancel. Okay, we want the x to come first, so this is going to be 5/7 x plus y equals 2. All right, so we're like in semi-standard form. Okay, the problem now is that a should be positive, right? If it's a fraction or a decimal, we have to multiply them to make them integers. So this 5/7 is a fraction. What can I multiply by to make this an integer, a whole, like -1, -5, -7, +5, +7, +3, just not a fraction? Okay, if I multiply the equation by 7, right, because there's a 7 in the denominator, so if I multiply the whole equation by 7, it will cancel. So I'm going to multiply this side by 7, and I'm going to multiply this side by 7. So 7 times 5/7 equals 5x. 7 times y is 7y equals 2 times 7 is 14. Now I have it in standard form. Okay, with that being the case, A is 5. 7 is my B, and 14 is my C value. Because remember, it was AX plus BY equals C. So that's how I can pick out those values. That's it. Putting it in standard form just means having your X and your Y on the left of your equal sign and leaving your constant on the right. Okay, that's all. Oh, shook my table. Sorry about that. All right, example 3. We're going to graph x plus 3y equals 4. So we're going to, now you could solve it this way, okay? It's going to take you more work, and maybe that'd be a good thing for me to show you, okay, if we plug in x. So we're going to pick our x and our xy's here, and maybe we say x plus 3y equals 4. Do not write this down. I just want you to watch how much work it's going to be if I don't change it and solve for y. Okay, so I'm going to pick -2, 0, and 2 again. Okay, so this is my x. So if I plug my x in here, I'm going to have -2 plus 3y equals 4. Well, wait, that doesn't tell me what y is. So now I have to balance this equation. So -2 plus 3y equals 4. So I would add 2. Then I would have 3y equals 6, divide by 3, and I would have y equals 2. So now I know here that y equals 2. I did all this other work that I don't have room for up here. So I have -2 and +2. Okay. Then I would have to do this, the next one. I would plug 0 in for x. So I'd have 0 plus 3y equals 4. Again, it doesn't come out with the nice y equals. Right? I have 0 plus 3y equals 4. So I have to do more work. So 0 plus 3y equals 4. That's the same as 3y equals 4. Then I have to divide by 3 on both sides. Y equals 4/3. So then I have 0 4/3. Okay, do you see how ugly and how much work this is? Now, what I want you to understand is this first step, okay, says solve the equation for y. So that's when I take this x plus 3y equals 4. And I want to get y by itself. So I balance. So I subtract x. So then I have 3y equals 4 minus x. And I divide by 3. Okay, so then the 3's cancel and I have y equals 4 minus x divided by 3. All right, so if I had put that into here instead, oh, there it goes. My eraser's a little slow. All right, so if I had put that in here, so I would have y equals 4 minus x divided by 3. Okay, sorry, I got interrupted for a minute. So I would have 4 minus -2 divided by 3. Well, 4 minus -2 is 6, divided by 3 is 2. Hey, right? This was a lot less work than all of this. And then for the next one, I would have 4 minus x, which is 0, so 4 minus 0 divided by 3. Well, that just equals 4/3. Cha-ching! Got it. And the next one, 4 minus x. X is 2, so 4 minus 2 divided by 3. 4 minus 2 is 2, so this is 2/3. So this last point is 2 2/3. All right, so then I'm going to graph it. So -2 2, -2, so 2 left, +2, up to 0 and 4/3, so that's like 1 1/3, and 2 and 2/3, so that's just below the line. All right, and it's a line, so I need to draw a line and put arrows on each end. Notice I draw my line out to the end of your graph, to the edge. That's always ideal. The other thing, you don't always have to pick -2, 0, and 2. Like here, the number 3 could have been ideal, or a number that would have went nicely, like 4 minus 4. You know, if you had picked 4, would give another number, or 8. Okay, you have lots of room. You don't have to pick, but it is always good to pick a negative number, 0, and then a positive number, okay, to get some variety across your graph. All right, on to the back. All right, so again, we're reviewing all things middle school related about graphing. Okay, intercepts are where the graph crosses an axis. Okay, so where the graph crosses an axis. The x-intercept is the point where the graph intersects the x-axis. Remember, this is your x. Okay, so anywhere along this line, where does it? So if I graph a line here, it crossed my x-axis right there. Okay, the y-axis is where the graph intersects the y-axis. Okay, so here's my y. So right here. And where does that line cross the y-axis? Well, right there. That's my y-intercept. So you can always, most of the time, you're going to have an x and a y. If not, that's okay. general, but most of the time, especially when we're first starting out here, you're going to have both an x and a y. All right, now, super helpful. So this is just me showing you, giving you an example. So hopefully you didn't copy that down. All right, so we're going to do example 4 on this graph. It says use the x and y intercepts to graph. So we can use these intercepts to graph an equation. So that's pretty awesome. The way to do that is we're going to use y equals 0 to solve for the x-intercept. I know we're going to put 0 in for y, and that gives us the x. That might seem kind of weird, but that's okay. We're literally just going to take this equation, 2x plus y equals 6, and we're going to solve it one time when y equals 0. So we're going to say, okay, 2x plus 0, because that's my y, equals 6. So maybe I should draw my line from the y. Like, I don't want to mislead you guys here with my lines. Okay, so we plugged 0 in for y. So then that just leaves us with 2x equals 6. We divide by 2, and x equals 3. But remember, we plugged 0 in. So if we're going to use this as a ordered pair, the x comes first, so it's 3, 0. Okay, because I put a 0 in for y, I got an x of 3 out. So it's 3, 0. So 1, 2, 3, and 0. I'm not going up or down. That's my x-intercept. That's where this line is going to touch or cross my x-axis. All right, now I'm going to use x equals 0 to solve. So I'm going to solve this equation again, but this time my x is going to be 0. Well, 2 times 0 is just 0. So this is 0 plus y equals 6, or y equals 6. All right, so my ordered pair this time, I plugged 0 in for x. So my ordered pair is 0, my y is 6. So 0 means I don't go left, or I don't go left and I don't go right. I stay right on the axis and I go up 6. 1, 2, 3, 4, 5, 6. So that's my y-intercept. It's on the y-axis. And then, like always, you draw a line and you put arrows at the end of the line. And that's it. So that's what step 3 is, graph the line. So you can tell in your homework you're going to have a variety of things to be practicing today. All right, example 5. Graph each equation, then determine whether it is a function. All right, so you'll notice these equations look kind of funny because all they have is one variable. This says y equals -2. This one says, B says x equals 3. Those are not typical. That means that the line is either going to be horizontal, it's going to go straight across the page, or it's going to be vertical. It's going to go up and down. Okay, so you have to think, this is telling you that your y's equal -2. I don't care what your x is. Okay, your x could be 0, but your y is going to be -2. Your x could be 3, but your y is going to be -2. Your x could be 10, but your y is going to be good, -2. Your x could be -5. What's your y going to be? -2. We do not care what the x is. It's just saying y equals -2. So that's a horizontal line. That's how you graph that. So would this be a function? Excellent. Yes, because it passes the vertical line test. Okay, so yes, function because, so B/C, it passes the vertical line test. My test there got a little hard to read. Okay, it passes the vertical line test. Okay, x. or on B, sorry, it says x equals 3. So anywhere my x is 3 is what I graph. Okay, so x is 3, here we go, at 0. X is 3, okay, I come over 3. If I go up to 4, I come over to x and go down to, what's that, -7. It doesn't matter. My x is 3. Anywhere on that place. Okay, 3 over is my line. So in this case, you see it's a vertical line. When I have an x equals, it gives me a vertical line. Is this line a function? No. Good. It is not a function. Right? And that's because it fails the vertical line test. It is a vertical line. But that's it. It fails the vertical line test. So it's not a function. All right, that is it. That's all of our review for 6-1. Again, like I said, I know that there's a lot of variety in there, but it's reviewing a lot of stuff from previous years that you should have learned about lines and graphing. And it'll give us a really solid start for this chapter. All right, I will see you guys later. Have a great one.